Taping electrical connections in motors can create potential safety hazards. Loose or improperly insulated connections can generate sparks or arcs, leading to a fire. Taped connections can also deteriorate over time due to environmental factors such as moisture, vibration, and temperature fluctuations. This deterioration can lead to loose connections, increased resistance, and motor failure. Furthermore, taping connections is not a recognized method of connecting electrical wiring according to industry codes and standards. To ensure safe and reliable motor connections, there are several best practices to follow. Firstly, install terminal blocks or screw terminals inside the connection boxes. This will establish secure and insulated connections for winding ends and power cables. Secondly, ensure that all wires are properly stripped, sized, and terminated. Thirdly, use appropriate insulation materials to protect connections from short circuits and electrical hazards. Fourthly, ensure that the motor is properly grounded to prevent electrical shocks and protect against fault currents. Fifthly, use explosion-proof enclosures for the connection boxes to meet code requirements and provide protection from hazardous gases and vapors. Sixthly, perform regular inspections and maintenance on the motor and connections to ensure proper operation and safety. Considering that the motors are made by Baltimore and US Motors, you may wish to contact the motor manufacturers for their recommendations on specific connection methods. Also consult with an electrical engineer or qualified electrician to ensure that all connections are compliant with applicable codes and standards. Train and authorize personnel to perform electrical connections safely and effectively. The use of terminal blocks or screw terminals provides a more secure and reliable connection compared to simply taping wires together. Terminal blocks provide a designated point for connecting wires, ensuring a tight and consistent connection. Screw terminals offer a similar function, using screws to clamp the wires in place. Both options help to prevent loose connections, which can lead to overheating and electrical faults. Proper wiring and insulation are also essential for safe motor connections. Wires should be correctly sized for the current they will be carrying to prevent overheating. Insulation should be in good condition and rated for the voltage and temperature of the application. Damaged or inadequate insulation can lead to short circuits and electrical shocks. Grounding is another critical safety measure. A properly grounded motor provides a path for fault currents to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The grounding conductor should be sized according to code requirements and securely connected to the motor frame and the electrical system ground. In a gas treating plant, explosion-proof enclosures are necessary to protect electrical equipment from hazardous gases and vapors. These enclosures are designed to contain any internal explosions, preventing them from igniting the surrounding atmosphere. Explosion-proof enclosures must be certified for the specific hazardous location and installed according to manufacturer's instructions. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of motor connections. Inspections should include checking for loose connections, damaged insulation, and signs of corrosion. Maintenance should include tightening connections, replacing damaged components, and cleaning the equipment. Ignoring these best practices can lead to several negative consequences. Electrical hazards, such as shocks and fires, pose a significant risk to personnel and property. Motor failures can disrupt operations and lead to costly downtime. Non-compliance with codes and standards can result in fines and legal liabilities. By implementing these best practices, the safety, reliability, and longevity of the motors can be improved and reduce the risk of electrical hazards in the gas treating plant. In addition to the above, consider the specific environment in the gas treating plant. The presence of corrosive chemicals or extreme temperatures can accelerate the degradation of electrical connections. Therefore, choose connection materials and methods that are resistant to these conditions. For example, use corrosion-resistant terminal blocks and insulated connectors that are rated for high temperatures. Also, consider using sealed or potted connections to protect against moisture and chemical ingress. Furthermore, pay attention to the routing and support of electrical cables. Cables should be properly supported to prevent strain on the connections. Avoid sharp bends or kinks in the cables, as these can damage the insulation and lead to short circuits. Use cable glands or conduit fittings to provide a secure and watertight entry point into the connection boxes. When making connections, use appropriate tools and techniques. Strip the wires carefully to avoid damaging the conductors. Use a torque wrench to tighten screws to the specified torque. Make sure that all connections are clean and free of debris. After making connections, test them to ensure that they are properly installed. Use a multimeter to check for continuity and insulation resistance. Perform a visual inspection to verify that all connections are tight and secure. Document all inspections and maintenance activities. Keep records of the dates, findings, and actions taken. This information can be used to track the performance of the motors and identify potential problems before they lead to failures. Following these additional considerations can further improve the safety and reliability of motor connections in the gas treating plant. Remember that electrical safety is a critical aspect of plant operations. By implementing best practices and staying informed about the latest codes and standards, the risks can be minimized and ensure a safe working environment. In summary, to avoid taped connections, use proper terminals, ensure correct wiring practices and installation, ground the motor, and use explosion-proof boxes if required, including regularly scheduled inspection and maintenance. These actions can improve electrical connections and motor safety overall.